episode 4 of our blog series, and today we're going to be talking about gravity and projectile motion. Now, if you ever stood on a scale, and the scale measures your weight in pounds, correct? And this is because the scale is measuring the amount of gravitational force between you and the Earth. So, if you were to convert this weight in pounds into gravity, but into force, then you will multiply it by 9.8 newtons per kilogram. And this only works on the surface of the Earth, and that is because that's the amount of force that the Earth puts on you. And that is why when you fall out of an airplane and you go skydiving or parachuting, you will fall at 9.8 meters per second squared, and that's the amount of force that the Earth is putting on you. Now, speaking of which, have you ever thrown a ball and you notice that the ball goes a certain amount of distance and then falls and hits the ground, correct? And this is because of projectile motion. Projectile motion has two different motions. One is horizontal and two is vertical. And vertical motion usually has to do with an object falling by the cause of gravity. Now, that's not always the case because the projectile can go up also. But as I'm sure you guys have heard, what goes up must come down. So technically that's also being dealt with by going down in a negative direction. So this is because of gravity. And gravity is pulling down this projectile at 9.8 meters per second squared, or 9.8 newtons per kilogram. So this projectile or object is being pulled down and is accelerating at 9.8 meters per second squared every second. So then what's horizontal motion? Horizontal motion is the motion of the object flying at a distance. And we're assuming, and so for example, if you're assuming no gravity and no air resistance, then the object will keep on going in that same direction forever. And at the same acceleration, with the same velocity, which should be zero because there's no force being acted upon that object besides the force of the actual object itself. Now, these two motions work together, but they are separate. So let's say I launch a projectile at 98 miles per hour, or kilometers per second, apologies. And that object will continue to move in the horizontal direction at 98 kilometers per second. But it'll continue to fall first at around 3 meters per second in the vertical direction, and then accelerating constantly at 9.8 meters per second. And this is why this object will eventually fall, because the object is continuing to move at the same rate horizontally, but it's accelerating downward at 9.8 meters per second. So, in the end, in projectile motion, gravity will usually win. Now, I say usually because think of an object in orbit, like the moon, as I explained in the last video. The moon's angular acceleration, or its horizontal motion, is greater than its vertical motion because gravity of the Earth is pulling upon the moon a lot, with the same amount of force that the gravity is pulling on the projectile that we just launched. But because of the moon's wanting inertia and wanting to keep on going in an angular direction or in a straight line, and then the moon is going to continue moving in that orbit around the Earth because of its inertia and its want to go away from the Earth. And so in this situation, and pretty much in this situation only, horizontal motion will win because its inertia is greater than the force of gravity. So I'll see you guys next time. And to sum everything up, one quick thing. To sum everything up, horizontal and vertical motion work together, but they are separate. And weight is a function of gravity, okay? So remember that your weight depends on the amount of gravity on the surface of whatever mass that you're on. So therefore, as I said, you can be 100 pounds on the Earth and 500 pounds on Jupiter. Really depends on the gravity. So I'll see you guys next time on episode 5, and bye.